Hello and welcome back to the Oxford MAT Livestream. I'm James, I'm the admissions coordinator for Maths at Oxford, and this week, logarithms and powers. I really like logarithms, I've been looking forward to this one. How's everyone doing? How are you doing today in chat? Let us know how things are going. Hello to, I can see Oscar and username A. I was having a conversation with an anonymous person before we went live. Here's Nikita Mazepin, a username that has, well, it didn't age well when you registered it, but hey, here we are. I was going to say age like milk, but we're really beyond that into some sort of like vintage cheddar now at this point. I'm Maya and Alex and Moses, and somebody in there has got the username e to the iPi plus 1 is 0. Good. And already someone's got in really quickly with a typo. It's entirely possible that there's a typo. I'm going to have to go and look now. But you've asked me about the solution to question 4. Oh my goodness. Yeah, have I factorised a quadratic incorrectly? Okay, I'm going to worry about that for a second. Oh, have I got the space? Have I got the base wrong? I think I might have got a base wrong. Is that the problem? Is it the base on the logarithm? Ah, somebody's got an A star in their end of year further maths test. Hooray! Congratulations. Well done to you in the A star in further maths in some sort of maybe in-school mock or something like that. Good stuff. Right, okay. Hello, don't know who I am as well. I like Slido. If you're watching for the first time, you can join this kind of slightly daft live chat experience that we've got running. I'm saying slightly daft because rather than running it through YouTube or something where everybody has to make a Google account or making you sign up, we're just using Slido, and it says Q&A, but we're not using it as a Q&A, we're using it just to put anything in there. Yes, thank you for the note on question 4. I'm wrong in the logarithm base, but I think, yes, and that was the only thing I asked you to do in the question. So that is on me. The only thing that was going on there is an error. Right, okay, I'll try and fix that at some point. Let's do, instead of doing this question about what to do is leaked or what to do with 3x3 determinants, let's do a quick poll for how's your day, because I know some people really like that. So let's switch that on. Yeah, there you go. Okay, you can let me know how your day's going. While you do that, I'm going to say a little bit about the MAT syllabus at the top there. The idea of this is that we're looking at the MAT syllabus bit by bit, piece by piece. It's supposed to cover AS level maths with, when we get to the last episode, just a little bit of the second half of maths A level or equivalent. One of the reasons we're doing this is because not everybody watching is doing A levels. So I know some people are watching because they want to compare what they've been doing in school through something like the International Baccalaureate or Scottish Highers or other international exam boards are available. You want to compare that to what we're doing in A levels. What does it mean, for example, when we say laws of logarithms on here? It means something in particular to people doing A levels. And I'd like to list several laws of logarithms at the start of this. But then the main thing we're trying to do is get people ready to attempt math questions. So I've picked out some multiple choice math questions, and I'm hoping that after about half an hour or maybe 40 minutes of revision and looking at the revision questions, we can do some math questions together. As always, if you'd like to get the questions before the start of the live stream, you can get those on the Matt Live homepage. There's a link on screen, or if you're watching on a device where you can get the YouTube description, it's in the YouTube description as well. That's got links to future worksheets for the next 3 weeks. I got ahead. I've been battling for time, but this time I actually got ahead. And we've got 3 more of these, 5, 6, 7, yeah, 3 more of these for the next 3 weeks, and the solutions there. So you could be looking ahead or working at your own speed. I finally caught up and then went beyond and got to the end. I'm very, very pleased with myself. Right, cool. People are having an okay day. 3.9 is good. We've seen better, we've seen stronger, but 3.9 is okay with a majority for 4-star vote on there. I always hope that by doing some maths today, that might be a helpful thing. Good. Okay, and an anonymous person says hi. Right. Okay, I'm going to toggle chat off just to make space. I can still see what you're saying in chat, so I'm going to keep one eye on that on this screen, but I just need I need the real estate for all my facts about logarithms. Right, I scroll here to scroll down. Okay, revision, let's go. So I've started with some rules about how powers work. I don't really know when people learn these, but it's worth doing these because I think they catch people out a little bit. It's these things like the ones at the top where you have 2 to the m, 2 to the n, and it's very tempting to believe that that's 2 to the mn, but it's not. It's not this, it's 2 to the m plus n. If you like the 2 to the m plus n, it means that you have m lots of 2 and then n lots of 2 all in a row, all multiplied together. How many of them are there? Well, let's count them. And when you're counting, you add together the separate numbers for how many you have in those two different subsets. So this seems to catch people out a little bit. Not as a standalone question, right? If I stop you on the street and say, hey, what's 2 to the 3 times 2 to the 4, you're going to get it right. But it's the sort of thing where in the middle of a question or in the middle of doing something else, you might get tripped up with how powers work. The next one is much harder. I really see people making mistakes with this. I mean, it's on the screen at the top, but at the bottom down here, 2 to the m all to the power of n. I mean, there's several incorrect things that you might think this is equal to. It's maybe surprising that it's equal to 2 to the mn, where again, it's lots of 2's multiplied together. How many are there? Well, 2 to the m, 2 to the m tells you there are m 2's, and we do that n times all multiplied together, means there are mn 2's altogether. I suppose this counting argument that I'm doing out loud is a bit reductive, isn't it? Because the counting argument I'm doing out loud tells you what happens if m and n are both positive whole numbers. In fact, it's true, these results up at the top are true for any real numbers m and n, which I suppose maybe I shouldn't be using this. Oh no, on the MAT Livestream website it says the MAT is on the 14th of November. That doesn't sound true. Oh no, I know what I've done. That is supposed to say that we're going to talk about the MAT 2024. Let us edit that now because that is confusing. Okay, I'm going to do some live website editing. Talking about MAT 2024. So no stream on 31st. Let's make that clearer. No stream date of MAT 2024. There we go. Okay, I've tried to make that clear on the website. Thank you. That is important. I think that's the first time I've tried to edit the website live during a live stream. Yeah, sorry. Date of the test is the 31st of October. 14th of November, a couple of weeks later, we'll do a special bonus live stream talking about it. Those are different. Woo. Woo. We're off to a good start. Thank you, chat. It's really good having this as a sort of live way to check in once a week with people who are using the website and stuff, in case I say something misleading or daft on the website. Thank you for catching me. Right, okay, I've got rules about negative numbers and things to the power of 0. We are trying our hardest to avoid talking about what happens with 0 to the power of 0. So we have a to the power of 0 is 1, provided a is non-zero. 0 to the power of 0 is sort of undefined. We don't talk about it. So I've tried my hardest to avoid. You see, I've put non-zero real number a in there. Okay. And then we get to some logarithms. Okay, pause here because I think I've rattled through powers really quickly. I thought I wanted to skip through to logarithms, but there's a chance that people would prefer to see logarithms. Prefer to see more stuff about powers. I don't really know how to do this, so I think I'm going to pause briefly, quickly show chat again. Chat currently says they saw 31st of October on the Maths Institute website, and that is the date of MAT 2024. You saw that on the MAT page, and that is correct information. See, okay, we got there to the kind of correct information, which I put on the screen. Good. Thank you, chat. Okay. Logarithms or powers? I think logarithms. I think we're rattling through things. Let's go over here. Okay. I see. Things are being archived. Right, okay. Sorry, I thought there was something going on with chat, but I think it's all right. I think chat is fine. Right. So there's this key idea. Yeah. Quick shout out. Hi. I think there's a person moderating chat. Hi. There's a current student moderating chat. Hello. You don't need to archive things. You don't need to mark things as for the archive. This unfortunately is now going to be out of order. Oh well. Okay. Yeah, people want logs. The people who've spoken, they would like logarithms. Okay. So what have I got? I suppose it comes from ultimately being able to switch between this idea that there's probably a correct choice of letters to use for this. But an equation like this, a to the power of b equals c, to switch between this and the idea that b is equal to log base a of c, this is something that you sort of need to get your head around as a kind of operation that you can do. Compare and contrast, right? If I had a times b equals c, then you've seen this so many times that you know that you could write b as c divided by a. Maybe you even have like a visualization in your mind of how the a moves from the left-hand side onto the right-hand side. Of course, if you have a plus b equals c, then you've really got this kind of mental image, perhaps, of how the a kind of moves onto the other side and there's a minus sign. And you've done the second and third line, those operations, you've done them so many times, you maybe have a kind of shorthand or idea in mind about how the a kind of moves over to leave b on its own. And what I really recommend is getting to the point where you can do the same thing for powers. Of course, it's tricky because you also have things like this, where you've got some sort of mnemonic for how to move this a onto the right hand side if it's up in the exponent on the powers. So you've got some intuition there for how to move the a onto the right hand side, and this line at the top, which again is the sort of powers logarithms relationship, looks very similar. But somehow, if you can get to this point where, I don't know, the logarithm kind of pulls down the a to just leave the b from the exponent. I don't know, I'm quite visual with how I like to imagine these operations happening. And how is the a being removed from the left and appearing on the right hand side? I have these other things in mind of the second one, the a kind of flying over and disappearing from one side and appearing on the other. Anyway, that kind of operation, or that link between those two ideas, needs to be pretty strong. Yeah, this kind of idea there's an inverse relationship. In each case, we're writing down the kind of inverse for the function. The inverse of the function adding a, or multiplying by a, or raising to the power of a, or finally at the top, raising a to the power of, which is the hardest one to say. There's mnemonics in chat. Yep. Base answer power as a mnemonic, which I haven't heard before. They've put BAP in capital letters in chat. Sorry for shouting the word BAP. I realised just after I said it that the plosive sounds probably sounded pretty horrible. Sorry, any headphone users. Yeah, so then there's questions in chat about change of base, which I've put in the exercises, in the revision questions, this idea about changing base, because I don't think it's taught as one of the sort of basic laws of logarithms in A level, but it's not that hard to work out. So if you had to, I think you could derive it using A-level maths. That's why I've put it in the revision questions, because I think you can work it out using A-level maths. And then once you've seen it, it's something that you, once you've seen a tool, you can use that for solving problems if you like. Yeah, could I explain how log base A of B equals log base C of... Oh, the question in chat seems a lot like one of my... Yeah, log base A of B is log base C of B over log base C of A. That is question 19, which I'll do hopefully after doing question 17 and 18 if I can on the revision sheet. Shrisht. Good. Okay. Okay. So we've got this idea about this being an inverse function, and then where do we go with this? I completely lost my space. What am I doing? Yeah, there are some special cases, which I'm trying to do with a general base, which feels a bit strange. I think maybe in school people learn things with log base 10 first, and maybe you talk about powers of 10 for a while and log base 10 for those. So I suppose maybe if you do those first, then you have to later at some point switch to a general base, and that can be a bit scary, especially if the question is using, if you're trying to do a question that uses multiple different bases, then it can be really weird. Maybe we should do some quick practice on this kind of idea that things like this are just quite hard to understand if you're only thinking about logarithms in terms of base 10. So there's lots of ways to read this. You could read this as log base 4 of 8. Some people put brackets in around the 8 just to make it really clear which bit's subscript and which bit's the base and which bit's not. So that nobody thinks it's log 48, for example. Log base 4 of 8. One way to read this is the number which you'd raise 4 to get 8. And another way of writing this is to say that it's x, where 4 to the x is 8. And that's an equation that you've maybe got ideas about, right? Maybe you see that and you have ideas to do with the number 2. Or am I going somewhere with this? Yeah, I think I am going somewhere with this, right? So if you see this equation, then maybe you see this 4 is 2 squared, and this 8 is 2 cubed. And then power rule, so it's 2 to the 2x is 2 to the 3. And then I suppose this is a logarithms rule to take log base 2 of both sides. But really I'm just comparing the powers to say that 2 to the x is 3. X is 3 over 2. This sort of thing is something that the more you practice it, the faster it gets, the more familiar it kind of feels. That, yeah, log base 4 of 8, I guess that's got to be more than 1, because 8 is more than 4, but not as big as 2, because 8 isn't as large as 4 squared. In fact, it's 4 root 4, so it's 1.5, so 3 over 2. That kind of gymnastics of being able to say, getting really familiar with the idea that you're raising the base to some power in order to get this number, can help you calculate them and also work with them just a bit faster. So question in chat, can I explain how a to the log base a of x is x? And can I talk about somebody in chat who loves complex numbers, I assume, says, is there a log base I? And I mean, is maths discovered or invented? But if you can define it, if you can explain what you mean by that, then maybe I'll let you do that. Logarithms get very complicated with complex numbers. Things stop being unique. I'm trying not to talk about complex numbers too much. Yeah, you can do I to powers, right? I to powers. There's this weird problem that I to the power of 5 is the same thing as I to the power of 1, which makes me feel quite nervous about the whole experiment, but you do you know, have fun, good luck. So yes. Am I currently doing revision questions? Not really. I sort of improvised a revision question, but I'm still kind of in the bullet points at the moment. I will get there in a second. Can I explain how to simplify this question? A to the log base A of x. Is that one of my questions or no? That's just a good question. It's just a good question. And this is about inverse functions as well, isn't it? So the question in chat is to show that a to the power of log ax is equal to x. Is this? Okay, so this is pretty close to the definition of the logarithm. The reason it's difficult is that this looks like quite a mess. So maybe we should give this a name. So let's give this a name. I just want to give it a letter or something then, like this. So if I write out y equals log base a of x, well, this is a good idea because it gives a name for this. We want to show that a to the y is equal to x. Giving things names is just really powerful. It can make the thing that you're trying to prove look simpler, which might help the pattern forming bits of your brain notice what's going on. For example, written out like that, we have a known statement, something that's true, because I just defined this to be true, y is equal to this, and the thing I want to show looks really familiar from the kind of definition of a logarithm or something, right? So if this is true, the next thing I can write down is then that means that, and let's try and do this correctly, a to the y is equal to x. That's just what the logarithm means. Yeah. So I know that looks really unsatisfying. And I know this thing I'm writing in brackets is a terrible reason. But then this thing that I've written down is exactly the thing that was in your question at the top. So this looks super unfamiliar, a to the power of log base a of x, but giving it a name converts it into a recognizable statement. This is something that I'm quite big on at the moment. I'm quite into this, trying to encourage people to do it, which is just start writing stuff down, give things names, or try performing random actions on the stuff in the question until you get it into a position where you can recognize something. We've got this set of flashcards for training yourself to recognize concepts. The flashcards are on the MAT Live website, and it's a series of flashcards for you to practice recognizing stuff. One of them has sine squared on one side, and you're supposed to look at it and recognize 1 minus cos squared, something to think of when you see that. But in order for that to be useful, you need to be taking steps with the questions to try and put yourself in a position where you can recognize something. Yeah, logs do sort of break in the complex plane. Somebody in chat is still talking about complex numbers. There's a lot of chat about complex numbers actually. Okay, good. So this kind of inverse function idea is, if you like, the idea that this y is a function of x over here. That's something you could graph, that's a function. And the opposite of that, or the inverse, would be if you swapped x and y, the other way around, if you swapped the inputs and the outputs, swapping maybe the letters x and y. If you do that, then you get a mess over here, but it's equivalent to a to the x equals y, which is something you've graphed before. We did graphs and transformations. We have graphs of a to the x. So this is kind of a nice relationship between y equals a to the x nice friendly thing we did last week, x equals a to the y, looks horrible, it's the inverse. That's the logarithm graph. Good, okay. There are people in chat now trying to work out what the math questions are, which is interesting. Okay. Okay, sorry, chat, this is worth putting, that's great. It's one of my favourite things about chat, and one of the reasons that I don't have chat on the screen all the time is that it just really like complex numbers. Someone in chat says, can you log base quaternions? Like, I mean, who's going to stop you? Yeah, look, so then there's loads of complex numbers. Just for clarity, there are no complex numbers in maths questions, the thing that I'm supposed to be talking about. No complex numbers because they're in further maths, which is a different A-level in the UK. So all the complex numbers are kind of locked up in further maths. There's a question earlier about what happens if you're not doing further maths. If your school or college doesn't offer it, then I suppose you don't have the opportunity to learn about complex numbers and stuff, but you would if you came to university, have the opportunity to learn about complex numbers, and maybe that would go really well. So if you don't have further maths because your school doesn't teach it, then that shouldn't count against you. And if your school does do further maths, then Oxford would normally expect you to make the most of that opportunity. Okay, right. Where did I get to on logarithms? Oh yeah, we're just getting to the gibbet. Oh, I found a to the log base of ax. That's where it was. There's a bullet point with no explanation. That's probably why you asked me about it, isn't it? Ah, good. I'm really forming a mental model of what people are reading. Because we've just got down to a law of logarithms. This thing, log base anything of xy is log base a of x plus log base a of y. I've said anything, but also realised that the base is really not supposed to be the number 1. Powers with the number 1 downstairs behave a bit differently from other powers, and the base on your logarithms is not supposed to be the number 1. I remembered that earlier, where I had an a not equal to 1 sign in there somewhere, but seem to have lost it down here somewhere. Anyway, if a is not 1, then log base a of xy is log base a of x plus log base a of y. That looks complicated, but it is just this rule written out. Do I mean this one? Do I mean this? I mean this one. It is just this rule, but written out with logarithms. I know that sounds impossible, but if you give each of these things a name and write down a logarithm sort of fact about each one of these things in that line, then you can convert this expression into the law of logarithms on the screen. You kind of have this option with logarithms, which is to convert any logarithm that you see into a power and then just deal with powers. I call this getting rid of the logarithms. You see a logarithm, you get rid of it by converting the thing into power. We're going to see that later on in some of these logarithm questions from the maths, where you can just kind of get rid of the logarithm. This makes me a bit sad because I love logarithms, and if the right thing to do is to just destroy the logarithm, then that makes me slightly sad. The proof here is something like this. So if you call this thing x, and you call this thing y, maybe I'll call this thing z, but really z is just, so z is just equal to x times y by the thing above. So this rule about powers, which is not very surprising or exciting, just says that, okay, the thing on the right hand side is the product of these things on the left. They've been multiplied together. Z is just x times y. Then in terms of logarithms, what do these mean? So in terms of logarithms, this one says that log base a of x is m, log base a of y is n, and over here, log base a of z is equal to n plus n, which is a bit mysterious until you realise, oh, this is fine. This says that m is just code for log base a of x, n is just code for log base a of y, and this last statement is pretty interesting. We can substitute these things in to get log base a of z. Oh, I've gone off the bottom of the screen. Log base a of z is equal to log base a of x plus log base a of y. Last step, remember that z is equal to xy, so this thing over here, maybe I should have written xy. And that's the law of logarithms. It says if you have a logarithm of a product, you can split that out into two terms. There's a question on the revision questions to do that, which is the one where I got a subscript wrong. I got a base of a logarithm somehow changed from a 3 to a 2. So we'll do that. How do you convert a log to a power? Logs are powers. So I would like it if you had these two facts as pretty much being equivalent in your mind. So whenever you see x equals a to the m, I'd like you to be able to swap that to the equivalent statement that log base a of x is m. And whenever you see a logarithm, like log base a of x being m, I'd like you to switch that to be able to switch that to x equals a to the m, which going this way, going in that direction, I call getting rid of the logarithm, or converting a log to a power, right? So we had this statement with a logarithm in, converted it to this statement up here with a power. Or what I'm actually doing on the board, we've gone from a statement with a power and converted it to a statement with logarithms. And the thing in the revision notes at the top of the screen there is just a sort of logarithm version of the power product of two powers rule, which is what I'm trying to do. I'm trying to take this kind of powers rule that I think people were happy with before and show you that the logarithm rule is really just the same thing, but repackaged using this one idea about how to translate between powers and logarithms. Translate in a kind of language sense, not in a kind of graphs and transformation sense. Okay. Chat is still talking about complex numbers. Okay. There is some more stuff you can do. So once you've seen that, you'll be, I think, unsurprised that you could do, if x is equal to y, then that left-hand side says log base a of x squared, and the things on the right, if x is equal to y, those will be the same. So we'd have two of them. And you can continue that idea to, what if you had x cubed? Well, x cubed is a bit like x squared times another x. And if you're happy that log base a of x squared is 2 times log base a of x, then there's another one. Good. Okay. Good question in chat. Is there an identity for log base a of x times log base a of y? And I'm not aware of a nice expression for this. I'm not aware of a way to simplify this further. Is that true? Do I believe myself there? As of now, yeah, no, I'm not aware of a nice way to do anything with this. If you like, logarithms turn. Oh, this is not going to go well. Logarithms turn multiplication into addition? No, I should not say that. That's not a very precise statement at all. I'm trying to describe the thing at the top of the page, right? Logarithm turning multiplication into addition. Addition of logarithms corresponds to multiplication of the numbers inside the brackets. So multiplication of logarithms maybe aligns with something much worse than multiplication, but don't love it. I mean, you could define a function. Let's not. Okay, it was a good question, but I think I should just say no, nothing like this. Yeah, okay. It is a bit of a fact. There's a discussion now in chat about whether that line at the top is just something you're given or whether you could theoretically prove it. And I'm never really sure how much of this you do in school, so maybe this is the first time you've seen a demonstration that it's equivalent. Oh, I guess you can go the other way as well. Everything here reverses nicely. These are just equivalent facts. Okay. My revision notes are quite pithy about the constant e. There just is this number e. It's about 2 and a bit, 2.7-ish. I debated when we put the course together for this MAT live stream. I thought about how precise to be about E, because if I say it's about 3, then that just looks really weird as a kind of fact to tell you that E is, it's a number, it's about 3. But if I say it's 2.718281828 459.450, people might think they need to memorize lots of digits. You don't. Knowing that E is a little bit less than 3 is enough, I think, for me. Okay. For our purposes, it's a special number. It does actually have a nice definition in terms of factorials, but for our purposes on the mat, it's just a special number. And everything works if you take E to be the base of your logarithms. People sometimes call that natural logarithms, and sometimes write them as ln of x. Although there's this kind of unfortunate truth that only holds pre-university. Usually at university, mathematicians switch to writing log, L-O-G, again, to mean natural logarithms, which is a bit unfortunate that you learn this kind of special notation for natural logarithm, and then later in life learn a different notation that's kind of similar to the one you learned for the general function. Sorry about that. And a question, before we move on to the revision questions, one more question in chat. So let's line this up and put chat back on. So I want to talk about some revision questions. Please could you let me know in chat which revision questions we should focus on. I'm getting the sense that the kind of sequence at the end, 17, 18, 19, is maybe interesting to people, and we should talk about 17, 18, 19 at the end. Are there other questions from the revision questions that you would like to talk about? Again, if you're playing along live, then you could grab the PDF and skim, or you could have a quick look at these 5 at the top and decide whether they look friendly or not. In a second I'll zoom down, but let's also take a question from chat. Do I need to apply to Oxford to take MAT? Yes. This year Oxford is the only university using MAT, or the only university for which you're eligible to take the MAT. So if you're not applying to Oxford, then I'm afraid you can't take the MAT this year. That is a change, but it's only a small change from previous years. Right, okay, people are coming in. They would like 15, 16, and I've already said 17, 18, 19. There's another request for 15 and 16, which are kind of the ones further down. Let's give it a moment just in case people want to request things higher up. While you're voting in chat, I will... Is it voting? It's not a poll, but okay. And there's votes coming in 13, 14. And then Shrish says everything down there, so some for 13, 14. These are large numbers. 15, 16, 17, 18, 19. There we go, okay. Yeah, and there's a sketching question on 16. Oh yeah, the hard bit of question 16. Okay. So Imperial are not using the MAT this year in the same way that they were before. Previously, Imperial applicants were eligible to take MAT, but this year that's not the case. Okay. Let's have a look then. So these first 5 I think are probably okay. I tried to make 5 look weird. On the left there I've got log base x of x squared. So log base x of x squared is just asking what number, let's do it in words, what number do you raise x to the power of to get x squared? Which, when you say it like that, is a silly question. You know what number you raise x to the power of to get x squared, it's 2. Or if you prefer, this log base x kind of cancels out the x down here, the kind of inverses, so this thing just simplifies to the number 2. I don't know if I've got that in my mind as a way of these things kind of fighting and cancelling each other out. I have to show them moving around and fighting. I don't know. I have to imagine it being animated. I think I've seen too much number file, too much, yeah, 3 blue 1 brown, where everything moves around and everything's animated. You know, that's how I think about functions now. Terrible. Good YouTube channel. Good animations. So get that here. Right. Okay. Simplification. Imperial is using TMUA as far as I know. Please check with Imperial and the universities if they want you to do any admissions tests. Okay. Yep. So then Joe says cube root of 2, which is then the answer to the question, because for the question 5 up there, we've got x cubed on the right hand side, which I haven't mentioned yet. You can solve x cubed equals 2. That's a little polynomial exercise for you there. X cubed equals 2. Cube root of 2. Nice. Okay. Is there an identity for log? This is a good question in chat. Is there an identity for log a plus b? I think the answer's no again, but for kind of the opposite reason. It would have to be something even more basic than addition, but not. What do I mean by basic? It's a good question. I'm not aware of anything nice to write on the right hand side. But anyway, having done the vote, I should probably skip down to the ones people actually want to talk about. I've tried to make the bases slightly weirder in questions 6 and 7. So you see question 7 has got x plus 5, and there's also x inside the brackets, but you can get rid of that logarithm. How do you get rid of the logarithm? Well, you do this, which is that you write down the sort of power statement that logarithm is equivalent to. And this is a good way to get rid of the logarithm. And now look, it's a polynomial. It's a quadratic. It's lovely. What is this? X squared plus 10x plus 25. Oh no, not 6. This thing. So this is x squared plus 4x plus 3. Oh yeah. There's a period of time where I wrote a lot. It's always this quadratic. Yeah, the quadratics, that same quadratic is higher up the page as well. Good, okay. Yeah, we can factorize quadratics and things, factorize things like that. 8's quite fun. 8 doesn't really work as a question, but I assess it anyway. It's a kind of fun exercise. The idea here is that you're using rules like this to rearrange these logarithms. That this is minus 2 and then 5. So then you could write that as like minus a plus b or something, which is then in terms of a and b. For the last one, which I saw one person in chat wanted, and maybe they got some thumbs ups, I thought you might know that 1024 is 2 to the power of something, possibly 2 to the power of 10. The number 1024 comes up in computer science and things, and binary sort of stuff, and the idea that a megabyte is not quite a million bits or whatever. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. It is 2 to the 10. This is 2 to the 10, but weight divided by 10 to the 3. And once I've written it like that, maybe you can see this is going to be some 2s and 5s kind of stuff. That 10 down there, well, there's 3 of the things before, isn't it? So this is 10 and 2 minus 3, a plus b, using like 3 of these previous things. Using, I guess, the fact that 10 cubed is 10 times 10 times 10. Yeah, okay. There's the first one as well. I made you do 1024 as the very first one. So I'd already made you think about how 1024 happened to be lots of 2s. This is quite nice because ln 1.024 is probably quite a small number because, well, log base anything of 1 is 0. What do you raise anything to get 1? You raise it to the power of 0. Log base anything of 1 is pretty close to 0, so this combination on the board is probably quite a small number. What is it? 7a minus 3b. Kind of quite small. Okay, combinations. Good. Oscar in chat says power of 10. And 9. So 9 kind of is a joke about hyperbolic functions. If you've learned those at school, you might recognize these functions. I think you can do this question though, even if you haven't. I think it's fun to just multiply out some exponentials. There's a reason why I picked these exponentials, but not a very important reason. if you multiply through, lots of cross terms cancel because the two things that we've got are pretty similar, but with different minus signs in. So there's lots of cancellation, which means that the answers are quite tidy. Some people learn about these things called hyperbolic functions, where you can then give things special names and interpret these as kind of identities to do with those special functions. I've got this meme in mind, which is people say you could make a religion out of this, right? You multiply all these exponentials together, and if you do it just right, all the cross terms cancel, and it's really beautiful. And you could give those things names, and then you could make a religion out of this. But okay, that's what I think of when people say, you could use hyperbolic trick. It's like, right, you've met the thing to do with this. Okay, 10 is just there to check that you can play around with the logarithms, do some kind of solve some equations like this. All of those things are related. They've got quite similar answers. So probably if you've solved one of them, then maybe you can explain how your solutions are related to each other. That might be fun. If you've tried question 10 already and you've got some solutions, you've probably found that they're related to each other, or that your answers are quite similar. Have a think about why they're related, how they're related. Okay, 11 and 12. 11 and 12 get a little bit too close to the powers of 1 and powers of 0 stuff that I was trying to avoid. So let's scroll a little bit past that. There we go. Okay. 13. It's my attempt at writing a log base 10 question for the revision questions, in case anybody really likes log base 10. So the first one up there says log base 10 of some stuff, which I haven't really read yet, is equal to 6. But as soon as I see that, I'm thinking, I should write out stuff is equal to 10 to the 6. It's just an option that I have, right? I haven't really read what this is yet, but the kind of pattern recognition bit of your brain, maybe, as soon as you see log base 10 equals, oh yeah, okay, this means the thing is 10 to the 6. And that's just what this logarithm statement means. Okay, then I look a bit closer and I realise that that says log base 10 of x is 10 to the 6. Oh, okay, so this says that x is, so again, 10 to the power of 6, which is 10 to the power of 1 million. So I guess there are a million zeros at the end of x, and 1 at the start of x, and nothing else going on. Okay, that's nice. 15, let's go. Okay. I think I've got down to a question that people actually wanted me to talk about, so let's get going, I guess. Let's do this for 15 minutes until we get to 6 o'clock, and then do some math questions. Okay, so 15 asks us to prove something about these natural logarithms. I think this is probably true for any logarithm base anything, but the question says natural logarithms, so we'll go with that. There's a plus or minus sign thing going on, so I think we want to show that, and then I'll write out what we want to show. Minus sign makes me think that it might be nice if we moved stuff onto the left-hand side. And then I have to get all my minus signs right. Okay. We want to show that this is equal to 0 if I add these things together. But we know that the left-hand side, we have an identity for this, is learn, and then I want to write out both of these things. Who remembers the algebra episode of the MAT Livestream? Oh, that's exclusionary, isn't it? If you haven't seen the algebra livestream, don't worry. There's a thing in there which is the difference of two squares, which I like a lot. A plus b, a minus b. I'm sure you've seen it, where a plus b, a minus b multiplies out to be a squared minus b squared. It's just really nice. So here I'm going to write out a squared and b squared. Oh, b squared is just this, isn't it? So that's this. Oh, but that simplifies really nicely. And now I'm kind of relaxed because things are simplifying nicely. The n squareds have cancelled. That's 0, okay. Which is 0, that's required. Okay. Good. So I wonder if people in chat who I was teasing a little bit a moment ago about the hyperbolic function, kind of semi-religion that forms around people who've seen hyperbolic functions. I wonder if you've seen these before. These are also inspired by things that are important when you're doing hyperbolic functions. Maybe not. Maybe not. What was my thought process to figure out moving it to the left-hand side? I suppose I thought I'd get rid of a minus sign if nothing else, and I'd have two logarithms added together, which I know facts about. Alternative, if you like, I could try instead leaving things on separate sides, but I could try bringing that minus sign inside. So alternative, let's go back in. Alternative, I could bring that minus sign inside. This is going to look very similar, I think, but be sort of different reasoning. Maybe this was the first thing you thought of? There's a minus sign outside logarithm? Seen that pattern before. Pattern recognition, right? Minus logarithm. Oh, that happens when you have logarithm of 1 over a thing. And then, well, I don't really want a 1 over. I want something that looks like the left-hand side. So I could try and rationalize the denominator. This is going to be a bit daft because I kind of want to multiply top and bottom by a plus root b or something. Try and get rid of that. Like if you have 1 over 3 plus root 5, I know this trick where you multiply top and bottom by 3 minus root 5. And then you kind of deal with the consequences. It gives you difference of 2 squares downstairs. So this is going to look very similar because I'm going to say, well, this is log of n plus root n squared minus 1 divided by. So maybe this is unsatisfying to you because this looks exactly the same and I'm just saying the same stuff in a different order, but my reasons for doing this are different this time round. The first time it was logarithms rules. This time it's more fraction rules, that you can simplify fractions like this, might be your reason for doing this. Then you discover that this thing underneath simplifies really nicely to give you the number 1, and everything's good in the world. What do we want to prove? That the sum is equal. Okay, so chat, what do we want to prove? That the sum is equal to 0. Oh, the other way. So one way to show that a is equal to minus b is to show that a plus b is 0, and then as one final flourish in your proof, aha, if a plus b is 0, then one more thing, subtract b from each side, and you'll be left with just a on the left hand side, and on the right hand side negative b from subtracting it on both sides. I guess I've done this enough times that I can switch between those two without really thinking about it, and I've realised I should have defended it a bit more, that if you're asked to prove that one number is the negative of a different number, you can just show that the sum of them is 0. A bit like if you're trying to prove that two things are equal, you might look at the difference between them and prove that the difference is 0. That's exactly what I'm doing here. It doesn't look like a difference because of the minus signs, but the difference between those two sides, it's got a plus sign in it. Oh, different suggestion in chat. Let's do -1. Yeah, okay. Yeah, rationalize the denominator. Great stuff. Yes. This. Aha. I think due to lag, they're about to watch me write that out on the live stream. Good. Okay. Okay. 16 wanted a sketch. The sketch is quite difficult for question 16. The function is something like, so after doing logarithms on both sides and rearranging a little bit, maybe you want to sketch something like this. So this thing, I don't need to tell you, is really bad near 0. It's actually very negative near 0 because this logarithm is very negative, and dividing by x just makes the problem much worse. So it's very negative near 0. It goes through 0 when x is 1, because log base 1 is 0. X is fine with that, just divides it by 1. And then it has a maximum and comes back down again. That's not obvious. The reason is that log of x grows more slowly than x. When you get out to 1,000,000, this is roughly 6 over 1,000,000, which is tiny. Logarithm tends to make large numbers much smaller. 10 to the 12. You take the logarithm of that, and you just get 12. So the logarithm of x tends to be much smaller than x. It's much less. So you get this kind of behaviour where this thing tends off to 0. That's a tricky sketch. It uses this idea that logarithm makes numbers smaller. Okay. Speeding up. Okay, right. So 17, 18, 19 is where we've got to. I think I've got some time for this kind of playing around. So 17 asks you to simplify this sort of thing. And it's written out like a power. So we could do a couple of things. One of them is that we could write this as a to the k to the log base a of b. But then that I'm confused. I don't really know what to do next. I'm sort of unhappy with this confusing thing to the power of log base a of k, log base a of something. I know we had that inverse fact before, didn't we? And this idea, after playing around with it, that the definition of a logarithm means that if you saw a to the power of log base a of b, then that would just be b. In that way, that a to the power of kind of cancels out logarithm to the base a. So maybe there's a kind of different route that I could go, where I write this as a to the log base a of b times k, which is a to the log base a of b to the power of k. These are both true. Everything here is equal. These are both true, but this one is useful. This is true but not useful. The second one is true and useful, because this is just b to the power of k. Yeah, b to the k, power tower in chat. Good stuff. Again, this is a skill that you develop when you're getting ready for university, I think. The idea that for a tricky problem, you might start going in one direction. This is you. You might start going in one direction and then realise that, I don't know how to simplify this any further. But actually you had a choice. You had a branch in the maze, or like a fork in the road or something. And if you backtrack a little bit, you could maybe try going the other way. We had this other choice about how to write this power down, how to simplify this power, which leads us to this kind of nicer way of writing it, where we can actually make some progress by saying a to the power of log base a of b is just b. Okay. Good. This is another key skill for tricky maths questions that I'm trying to tell people about, the idea that you can backtrack and try something different. So we had the tip earlier to just try writing stuff down until you recognise things. The second one is to, if you don't recognise anything, it's okay to backtrack and try writing down something different. Give yourself a second chance at recognising something. So if you write down both of these, then you get a chance to recognise this one from, oh gosh, somewhere halfway through the revision notes or your previous life or a maths lesson or something. Okay. It's one of those times that I did something wrong, but kind of on purpose. Not to be confused with the times that I did something wrong, but accidentally. Those also happen. Okay. Myra just decided to do a sort of update, so that's fun. Good. Shusheng is in chat answering questions. I can't see their answers, but thank you, Shusheng. Okay. Cool. Good. Okay. So question 18 has this horrible number x. Consider this number, which is log base a of b times log base b of c. and we're asked to simplify a to the x. So we have a to the power of log base a of b log base b of c, which is, I suppose, well, I've seen this trick now. You write this log base a of b to the power of something else, and then inside the brackets I've got something that I could copy out as being just b. That the a to the power of cancels out the log base a, to just leave me with b. I suppose the difference here is that then I get to do it again, which is that I get to write down that this is b to the power of, well, now I wasn't really paying attention to what this was as I write out these lines, but this is b to the power of log base b of c, which is just c. So I've got, after simplifying quite a lot, I've got a to the power of something is just c. So I have a to the power of something is just c. Oh, I've given this a name. This is called x. That just means that x is log base a of c. And at that last step, I'm doing that thing, switching between a to the power of x of c and switching from that to a logarithm statement, log base a of c. If you like, the a is moving onto the right hand side with some sort of like logarithm way of moving it, or if you prefer, there's log base a on both sides, which is then simplifying this thing and turning up on the right hand side. Okay, and final step, and these three parts together form a kind of little proof about something nice, which is we have log base a of c. That's the thing we discovered x was equal to, log base a of b log base b of c, which is already cool. If you read it, maybe it's helpful to color code things. I have log base a over here, and then there's a b in here, and there's a c over here. So it's kind of pink downstairs of purple, purple downstairs of pink, but the purple things kind of cross cancel or something. I'm not sure I've got this one in my head. Is there a particular reason for us to consider a to the power of x instead of just changing bases? I'm trying to prove the way that change of basis works. So if you've learnt change of basis as just a fact, then this is a proof of how that works. The thing I can do at the end here is to divide through. To take this fact and just divide through. So move this onto the left hand side. Log base a of b is just log base a of c divided by log base b of c, just by dividing. So if you've learned this, have I messed up? Maybe I've messed up. Have I divided by the wrong thing? Yeah, I divided by the wrong thing. Or relabeled or something mad. What did I do wrong? Can't even tell what I've done wrong. Well, look, whatever. So I'm supposed to divide by the other one. Is that what I was supposed to do for this question? Mean. Yeah, I'm supposed to divide by the other one. Okay, I've got devised a different rule. Also true. I'm just getting loads of free facts from here. I could divide by this thing instead, in the middle, to get log base a of c divided by log base a of b is equal to log base b of c. 2 for the price of 1. Do I believe both of these? Yeah, sure, why not? Don't really believe the top one. Am I just wrong? Am I spreading misinformation about logarithms? I don't think I'm spreading misinformation about logarithms. I think I've just got 2 things at the same time. I've mildly confused myself. Yeah, I believe both of these. Good, okay. Maybe this is a demonstration that you can work out new laws of logarithms from the existing ones. Good, okay. Right, I think it's time to move on to some actual math questions, if that's all right. before I discover any more laws of logarithms, some of which are probably going to be wrong. What have I done? I'm going to think about that, but instead of getting you to think about that, that's my problem. I'm going to get you to think about this, which is sketching a graph of a particular function. Let's go full screen for this if we can. Clock, there we go. This is a multiple choice question where all of the options are graphs. So we're looking for a graph that's the graph of the function log base 10 of x squared minus 2x plus 2. And we've got 5 options that all look a little bit different from each other. I'd like to know in chat, if you want to join in chat, not just which one would you pick for the graph of log base 10 of that quadratic x squared minus 2x plus 2, but also why. What gave it away, or what was important to you when comparing these graphs? I haven't quite been able to scroll, so that can I scroll out a little bit? Don't think I can. I'm going to spend 10 seconds trying to set that up properly. There, and then I put that and that, and I get this back, and I get this back. There we go. Okay. I think I can even have chat on. Let's find out. No. Yes. Okay, I can have chat on. There we go. That's kind of hiding one of the graphs. Let's hope you're not hiding an important graph, chat. Set y equals 0 and check roots. I like that. Let me think about that. So that would be the question, when is log base 10 of this quadratic equal to 0? That's a bit like saying, when is the quadratic equal to 1? Which is an equation you can work with, right? X squared minus 2x plus 2 equals 1. It's a quadratic. What's the answer to that? Oh, I think I know the answer to that. Subtract 1 from both sides. It's a quadratic I've seen before. What does move k up mean? Move k up. Is that an instruction to me that I should move something somewhere? Or are you moving a graph upwards? And then I like this. So one person is talking about setting y equals 0, and the next person next to them, a different anonymous person, I think, is talking about something slightly different. There's some folks coming in for E. Hannah completed the square, love it. See a quadratic, why not complete the square? Keller's looking for when the quadratic is equal to 1, but careful, it's not an asymptote there. That's where it's the logarithm 0. Logarithms are okay if you put the number 1 in, not great if you put the number 0 in. And then people are looking for a root at 1. Sophie checked what happens when you put in x equals 1. I like this, okay. So when x is 1, Oh, that works really well actually. So if you just look at x equals 1, then you get 1 minus 2 plus 2, which is 1 inside the brackets. And the value of x equals 1, you've got log base 10 of 1, which is 0. And actually, I think only one of the graphs has log base 10. Well, when x is 1 has the value of 0. You get a root at x equals 1. So people have gone for E, I think. Right, okay, yeah, okay. Keller has changed to E as well. And Trish is chimed in, x equals 1 is root, so E. Nice, okay. I like that, and I like the way we had different different arguments coming as well for checking what's going on. One more from an anonymous person. Checking what happens when x is 0. So like Sophie checked x equals 1, this person's checking what goes on with x equals 0, where it's log base 10 of 2. No, I'm not sure. Oh, but then no, they're talking about the gradient. They're talking about how it's decreasing. What happens there? X squared minus 2x plus 2 is decreasing when x is 0. Yes, the gradient is minus 2. So log there is also decreasing. We're giving it smaller and smaller numbers, smaller and smaller positive numbers. So it's decreasing. There are 2 options that are decreasing. So C is also decreasing when x is 0. But you're pretty close to just saying it's E. I like that. All these different, it's so nice seeing people using all these different, things they know about quadratics, about increasing and decreasing functions, about completing the square, about looking for roots or solving the equation. X squared minus 2x plus 2 is a new thing to check. When is the thing inside the brackets equal to 10? Because then we'll get the value 1. And I don't know the roots to that equation. I guess it happens a couple of times. Maybe 1 positive, 1 negative. That could be A though. Okay. So some of these rule out lots of options, and some of them rule out most of the options. Maybe people have got a combination of options. Or hey, maybe all these are anonymous. Maybe all these anonymous people are the same person who's had like 10 different approaches all at once. I've got my eye on this anonymous person, this sort of super user with lots of ideas. When I was doing some math questions, I skipped out some maths questions since I'm applying for CS. You can choose. So the question there about skipping central questions is because on the past papers, question 3 and 4 were not taken by computer science candidates. Recently, question 3 was taken by computer science candidates. So even recently, I would say have a look at question 3. Question 4 was usually some sort of geometry question, which the computer scientists didn't do. That's it. The geometry on the MAT is it's the same syllabus as it is from the multiple choice questions. So there's stuff there. You would still be practicing even if you just looked at multiple choice questions. So it's up to you. If you want to see some tricky geometry questions, I think we've got a geometry live stream in a couple of weeks. You can watch that if you like. You don't need to apologise for being late. You have a choice. You can watch live. We're doing the MAT questions now. Or you can rewind and watch some revision. There are no calculators in the maths admissions test, I'm afraid. Our friends at physics have calculators in the physics admissions test, but for the maths department, we have no calculators in our maths admissions test. I'm sorry. By checking x equals 0, you meant checking the value. It's certainly not 0, and a lot of those do go through 0. Okay. Right, okay, yep, okay, I like those options. Good, okay, next one. Can I fit this on with chat as well? Yeah, okay. I kind of want to zoom back in. No, we'll keep it this size for a little bit. This is nice because we've got chat going at the same time. Next question, 2015 question 1H. This is, I use this one a lot. If you came to an open day, then during the open day, the Maths at Oxford talk, you might have seen, if I was doing it, you might have seen one example of a math question. I had one slide to put one math question on, and I put this math question on because I love it. It's so awful when you first see it. It's so crazy. Sophie says, James, I don't think you replied to people earlier. I definitely talked about it. I also edited the website live. There is no confusion. The math is absolutely on the 31st of October. One person had seen the website where we're doing a bonus live stream talking about the test after the test and got confused, but we fixed that. We edited the website and I talked to them. Shall I also put it in text? I'll put sorry in there. Okay, right, cool. No problem. Okay. Right, okay, we've got a horrible logarithm on the screen. Maya wants to unlogarithm it. Unlogarithms your equations. Oh no, my equations. And then it gives you a polynomial 4 minus 5x squared minus 6x cubed is equal to, and on the right hand side you're going to get some sort of mess, x squared plus 2. Let's switch to this one so that I can write as well. So the suggestion to unlogarithm it gets us from log base b of c equals a. Aha! I always want to write down this. That's a very wobbly 4. Something like this. And now we get to relax because now it's a polynomial question. This step is so good. This step is take x squared plus 2 to the power of both sides. It's just, never the right thing to do. You never see an equation like 1 plus 1 equals what, and you're like, wait a minute, I'm going to try x squared plus 2 to the power of both sides. It's never the case that helps, except that is what's happened here. How did you make progress with maths question? Well, I just picked this quadratic and I raised both sides to the, I raised the quadratic to the power of both sides of my equation. And then it does turn into a sort of, it looks horrible, but it turns into not too bad an equation because this is 4x squared. The 4's cancel. So you get this kind of nice equation, which in chat, Pure Maths Greater Than Stats has told me that this is a cheeky hidden quadratic, which I would make, especially if I write the terms in the right order. I should put the cube term next, shouldn't I? If I'm going in decreasing powers. There we go. And then I can write down my 9x squared. I've spotted that this is this. Again, if you want to take 2 or 3 lines to write that down, that's fine. I want to take 1 line because I don't have much space on the screen. And because I've multiplied out some squares in my time, I know that when you have a square number here and twice the square root, I've seen those before. So I'm happy to do that in 1 line. If it's 2 steps for you, that's fine. Take your time, get the right numbers. Importantly, these are repeated roots. X equals 0 and x equals minus 3. I'm sure everybody went back and checked their answers. I'm sure you check your answers all the time when you're solving equations. We should go and check our answers, right? We've done some weird steps of solving equations and messing around with logarithms. We should go back and check that 0 actually works back in the original equation. 0 is one of the numbers that I get scared about putting 0 into logarithms. Here it's fine because there's this 4 that's going to save me. I put 0 in here, and I know that's 0. I put 0 in here, that's also 0. I'm a bit nervous that we might be putting 0 into a logarithm. Something I'm not supposed to do, but there's a 4 here. So we're putting 4 into a logarithm, and it's got base. Well, I probably shouldn't have base 0, but there's a 2 here. Log base 2 of 4, which really is 2. And then the other root corresponds to, did anyone check? Corresponds to log base 11 of 121. The number in brackets just works out to be 121, which really is the square of 11. So that one works as well. There are two solutions. Okay, let's go back in. There's a chat. X equals 0 and x is minus 3. There we go. Will every math multiple choice question have 5 options to choose from? That is what we've done in recent years. Is that true for Math 2024? No comment, sorry, I can't remember. I think it's true, don't want to promise. Okay. Someone's telling me about asymptotes. Yeah, they've noticed back up here. They're thinking about the discriminant of a quadratic. Worth highlighting because it's another fact about quadratics. I'm so pleased with that question. There's so many quadratic facts that you know. Okay, what did we pick? I picked C. There are 2 solutions to that equation. And we're moving on, I think. Question 1I, which I'm going to switch off chat on the live stream, on the camera. Oh, not if I press that an even number of times. I have a new hotkey for this. Why is that not going off? My hotkey's broken. Yep, no, it's not happy. Okay. Don't tell chat you have a hotkey if your hotkey also doesn't work. Okay. Also, if it's a hotkey for turning off chat on the stream, it's just rude. Right. Okay. Sorry for being rude, chat. I can still see chat on the screen, but I have a new question on the screen, which, oh my goodness, looks even worse. There are logarithms. There are powers. Inside that bracket, it says b to the power of x to the power of x again, which is like iteration of the exponentiation, which is fun to say, but not very fun to work with on the page. There are fractions, there's logarithms with 1 over b. Where do we even start here, right? We're looking for whether or not this equation has a repeated root, whatever that means. What's the aim? What are we going to try and do? So at the moment, I don't know any facts about 3 log terms, 4 logarithms, some of them added, some of them multiplied, different bases, some of them are base B and some of them are base A. I don't know any rules about that expression. It's not, it doesn't spark joy. It doesn't remind me of any of the flashcards turning things over when I look at the whole thing. But maybe you've got suggestions. Yeah. Start by, okay, so I like Imo's suggestion in chat, which is to simplify the leftmost term, break it down, do one term at a time. And Moses is telling me to find a quadratic. Anonymous person says find a hidden quadratic again. I've put these 2 questions next to each other. We've got a little bit of a theme for this page of the worksheet of quadratics and logarithms. Trust the process, it works, says Maya, which, yeah, is true. If you simplify each thing down. I don't actually know any other ways of doing this other than simplifying it. I guess make it more complicated, then simplify it? No, I just really have to deal with the fact that I don't know how to solve very many equations, or talk about roots of very many equations at all, really. It's kind of just polynomials, and if you want information about where the roots are and whether the root's a repeated root, then it really has to be a polynomial of quite low degree, like a quadratic or something, so that I can do that calculation. There's all sorts of like horrible equations, like x to the power of x equals 3 plus log base x of 2, that we can't do anything with this. You can't do anything. And this looks like one of them at first sight, but it's not too bad. Yeah, so we're going to try and get this into a quadratic, simplify, and then maybe we could take the discriminant, or maybe we could factorize. I want to talk about both of those. So let's do some logarithm simplification. That's what we're here for this week, I think, is to take things like this and say, well, hang on a minute. You've got a power of x inside this logarithm. And when I see a power of anything inside a logarithm, I'm sort of imagining that we have this option to move it outside. I'm going to put these brackets in as well, just to make it clear that the stuff inside these brackets doesn't matter to me right now. All I'm seeing is thing to the power of x inside the brackets, and I'm moving the x outside. Although it's the letter x, that shouldn't scare us. And we've got this big general rule that if you see a power inside a logarithm, you can move the exponent out. That works whatever letters of the alphabet you've got. Even though in this context, the letter x is special, it's something we're trying to find roots for, we're looking for solutions, whereas b is some sort of fixed constant that's positive. Doesn't matter, just move the number out. We could do that again, because this is this. And so far, the base hasn't mattered, because this general rule about moving exponents out is true for any base. But maybe now I notice that, oh yeah, look, log base b of b, what number do you raise b to in order to get b? The number is 1. This is just x times 1. So this is x squared. Maybe you did this in 1 line, and I've taken 3 lines. So well done if you've done that faster. But this is a sign that we're looking for maybe some sort of quadratic equation. I'm going to do the other 2 slightly faster. So this one, log base a of c to the x over b to the x. Now maybe I should write out a line to tell you that, maybe I should write out a line to tell you that this is c over b to the power of x, but maybe you'll let me get away with just writing this like that. And finally, this last one. Well, what do I want to do here? I don't know any rules about logarithms multiplied together. I suppose I do know that this thing is minus log base a of b, which is not too bad. I quite like that. Maybe I want to write this as, it makes me think I've split apart. I've got kind of b and c separate over here, so maybe I wanted that over here. You don't have to do this step of simplification. I'm not actually sure that I'm simplifying. I think I'm maybe just playing with my food, messing things around, and actually get to the point of writing out the quadratic. So we have overall something like, that first term is x squared, the second term is x, and I've decided to write it like this. Maybe you left this as one term. Not obvious to me which way around is going to be easier. And that's 0. So we could use a discriminant. We've got a quadratic now. If you squint, there's x squared here, this is a coefficient of x, this is a constant on the end. So we've got a quadratic, we're looking for a repeated root. We could write down the discriminant. That involves squaring the middle coefficient and subtracting 4 times the product of the outside coefficients, something like that, b squared minus 4ac. I don't really want to say b squared minus 4ac, right, because a, b and c are already in the question. So middle thing squared minus 4 times the product of the outside things. That feels like a bit of work, and there's some chance that I get the a, b, c mixed up with what the actual coefficients are versus what a, b and c are, so I'm a bit nervous. I think it's easier to factorise. Maybe you learned this before you learned the quadratic formula. You learned if you can spot a way to factorise, then that saves you all the work. You can just write down this factorisation. Here, I think, after playing around with it a bit, I think this works. I saw this in chat a second ago, so I'm sort of cheating by copying it out of chat, but thank you, don't know who I am. I don't know who you are, but you've helped me out here. Factorise is like this. I guess that by splitting these terms apart, I have this, I was already thinking about this as a difference. Yeah, you need 2 numbers to multiply to make the constant, and the add to make this coefficient. And this thing's clearly the product of 2 things. I guess that's the sum if you include the minus sign. So maybe you could spot that kind of product and sum kind of way of splitting this into 2 terms. If not, then that step looks like magic, and I'm sorry for that. It's not supposed to be magic. I'm trying to justify that I spotted some product and sum, and so did someone in chat. If that looks like magic, then you have this alternative to calculate the discriminant. Anyway, if this is a repeated root, then these things are supposed to be equal, including the minus sign, which means that c should be 1 over b, so that these terms can be equal, including the minus sign, which is d. Nice. Okay. Doesn't involve the letter a at all in the answer, which makes me think maybe there's a way to attack this question where you consider changing the letter a, and you realise that if I change the letter a, then it'll change both roots, but it'll change both of them in kind of the same way. So if they were the same before, they'd stay the same, and that changing the letter a doesn't actually change anything about whether or not they're repeated. That sounds complicated though. If you're thinking like that, then that sounds very clever. What would that be? So the first term is always the same. As you change a, you're changing the base of the logarithms for the other 3 logs that are printed in the question. I don't love it. Can we do something with that? Could I add them together? I've never tried to do it like that. No, because I've got the product of the 2 logarithms. That's not going to work. If that last term had a plus sign in the middle, it's a multiplication, then we could do a lot of tricks of moving some logarithms around. Could bring them into the middle term. See what they want to do over there. Okay, instead of me trying to do hypothetical questions that are not on the screen, I think we've killed this one. Simplify each term. Aha! A quadratic. Familiar ground. The mini theme of quadratics and logarithms ends there. I'm reading ahead. Yes, it does. Okay. Those were good. Here's some more. We've got more things to try. Okay. Here's 2008 question 1b. This is from back in the day where MAT questions only had 4 options. In fact, the ones on this page are from 2012 backwards. There are only 4 options. we added a fifth option in, I think, 2014. Questions started having 5 options. Okay. Which is the smallest of these values? And I think I'm going to want a reason why. We've got in chat. In chat, it just says DAD, which is almost consensus, but not quite. There's another A. Chat now spells dada. Right, okay. So we've got several things in here. I think the connection is that they all involve log base 10 of pi. I don't know anything about log base 10 of pi. If I really think, then 10 is about pi squared. You know, is that helpful? No, that's not helpful. What do you raise 10 to the power of to get pi? That's a daft question. About a half, I think. Roughly square root 10. Yeah, I think I've seen that. It's like square root 10 is about pi. So I guess log base 10 of pi, this is 10 to the 1/2. And for the 100th times a day, whenever you see 10 to the power, you're going to be able to flip that over. So I guess this is about 1/2. Okay, cool. Not in the question. Maybe not useful. Not sure. Yeah, pi is in chat. Pi is a good approximation of square root 10. What's this? The other way around, right? If you need square root 10, then maybe use pi. Okay. So then, what have we got? These numbers are, I'm going to call it alpha. These numbers are alpha. Square root of, now what's that? That's not alpha squared, is it? That's 2 alpha, bringing out that 2 from the exponent like we did just before. And then we've got alpha to the -3, and then I've got to bring out 1/2 here. So this is root pi. Root pi is pi to the 1/2. And when you see an exponent inside your logarithm, you've got to consider bringing that out to give something like this, but it's all 1 over that. So it's, what is that? 2 over alpha. Okay, something like this. Yeah, like AB log 10 of pi is a good idea. So then, yeah, we need to decide which ones of these are biggest. I guess A, or alpha or whatever I'm calling it. It was X in chat as well. What do you need to know? The smallest of these values. So I think if this is about 1/2, then I think they're about 4, 8, 1, and 1/2. So I think it's this one as the smallest, option A. But I want to try and make that more precise, I think. If I had to answer this multiple choice question right now, I think I would go A, just because, well, roughly speaking, they seem to be about 1/2, 1, 8, 4. So maybe I could try and prove that these two are larger than 1. If I think this one's about 1 and this one's about 1/2. How would I do that? So sometimes it's a good idea to just start writing. To show that this thing is bigger than 1, if I think this time, because I think it's about 8, so I should be able to prove that it's massive. To show that it's bigger than 1, I'll show that, again, maybe for a multiple choice question, I suppose I don't need to do the layout. I don't need to lay this out like a proof or whatever, but it's good for us, I think, to practice that sort of thing. If alpha is smaller than 1, then when you do 1 over alpha cubed, you'll get something big. When does that happen? Well, okay, when alpha is less than 1, but alpha is log base 10 of pi, and pi is less than 10. Log base 10 is an increasing function, and it hasn't yet got to log base 10 of 10, which would be 1. Okay, so I've used the fact that pi is less than 10, which is a terribly imprecise statement about pi, but I think it's good enough to convince me that this is larger than 1. And maybe this one as well. If alpha is less than 1, then this thing is larger than 2. Yeah, good. C and D is smaller than 1. I think they're larger than 1. Yeah, good. Okay, there's people in the chat agreeing with Maya. Since C and D are larger than 1, you only have to think about A and B. And now I've become a bit worried that I think this one is about 1/2 and this one about 1, which are quite close together. But people have got this kind of compare the squares strategy going on in chat. So I'll follow chat. Something you can do if you have positive numbers is you can compare their squares. I can't remember if we've done this on the stream before. Have we had that question about comparing lots of numbers to find the largest one where there's lots of square roots around? I don't know. So we could do something like this. Do alpha versus 2, where you do the same thing to each side. And then you realise, oh, hang on a minute, I know that alpha is much less than 2. It's less than 1. So alpha is less than 2, alpha squared is less than 2 alpha, alpha is less than root 2 alpha, and you can replace all the versus symbols with less than symbols. Now, as long as you do operations that preserve the inequality, that keep it the same way round, then at the end you can come back and just put in, aha, I've decided which way round these inequalities go. Wait, am I just wrong? Am I wrong? Yeah. Okay. Chat's disagreeing with me, which makes me very nervous. Very nervous. But I think I'm there. I think it's A. I think this thing is the smallest. I think this thing is the smallest because, well, just knowing that alpha is less than 1 seems to be enough, because once you know that alpha is less than 1, these last two are enormous numbers, partly because this is multiplied by 2 and partly because this is like something minus 3. They're much larger than 1, and this thing is, well, if alpha is less than 1, this thing is, I guess it's, yeah, this thing could be, couldn't it? You have to do the comparison for these two. Okay. Yeah, smaller, so alpha is, A is smaller than B. And I guess I've only used the fact that alpha is less than 2 over there. Sorry, I'm really thinking about this way too much and just talking to myself quite a lot. I don't think I'm talking to anyone at home. Sorry for the rambling. I've become interested in what facts we're using along the way. Like, what are we expected to know about log base 10 of pi? And I think it is just that pi is less than 10. And for this last bit, the weird thing that's really making me pause is that I think I can prove that A is smaller than B just by using the fact that pi is less than 100, which feels very kind of, there's a lot of space in there. It is A, isn't it? Did this question earlier and it was A. Thank you. Okay, it probably hasn't changed over time. It's probably still A. It's maybe been A ever since 2008 when it was set. Yeah. Oh, right. Okay. Quadratic. I like that. There's a quadratic in chat. Continuing our theme of quadratics and logarithms. They've told me to set this polynomial like this, negative, to work out when is x squared take away 2x negative. When is it true that alpha squared is less than 2 alpha? Well, that happens when x is between 0 and 2. Yeah, so it really is just true all the way out to 2. Right, in the context, 2 feels like quite a long way. I think we're actually over here or something. All this free space. Okay. Can make that question harder. You can make the question harder. It doesn't need a factor of 2 over there, and it doesn't need a factor of 2 inside here, does it? No. It's got these factors of 2. Should make the question easier by making B and D larger by a factor of root 2 and 2 for, I think, no reason. It really is A. I'm moving on. Some of these questions puzzle me just by having extra factors of 2 in that make the question easier than I was expecting. I don't know. Maybe I'm reading way too much into it. Here's a question about powers. No logarithms, just powers. We've got some polynomials to multiply out, I guess. Let's not. Hopefully, oh gosh, it's really high risk, right? I think quite a lot of people download the worksheets for this, and it's quite high risk that one person out there is multiplying out all the brackets. And I say is present tense because they're still going. There's no chance that they finished. This is a big risk because even if one person starts multiplying out all the brackets, then the amount of person time that will be spent on multiplying out brackets. I'm being silly. Obviously, we're not going to multiply out the brackets. Obviously, you didn't multiply out all the brackets. What did you do instead to find the highest power of x that you get if you were to multiply out all of these brackets? There's something quite pretty about the hierarchy of brackets, right? It's round brackets on the inside, then square brackets, then curly brackets around the outside. Ow. Curly brackets around the outside with just a power of 3 around the outside. I think there's 2 ways to think about this. There's kind of an inside-out way to think about it, and there's an outside-in way to think about it. So let's see what people have got. From focusing on, let's see, will these be the 2 different ways of doing it? Let's find out. Moses and Tristan Anonymous are in chat. Do get in chat as well. Somebody says this feels like a searching algorithm thing and it's fun. That's nice. That's, I think, the first time in the MAT Livestream 2024 that somebody's described a question as fun. So that's good. Yeah, so you're either, that's a good way of thinking about it, either the first term or the last for these expansions of where there are just two terms to some power. It's either going to be the first thing or the last thing. The powers of x will either be increasing powers of x or decreasing powers of x. If you write them in order, which makes my statement sound silly, but hey. Yeah, okay, good. People are still in chat, people are still backing me up in selecting A for the previous question. I think they could see that it was causing me some mental anguish, but I've become happy with picking A. Okay, thanks chat. Good, okay. People have looked for the highest power by imagining what would happen. So if you see, oh hello, what's happened there? 2x to the 6 plus 7 all to the power of 3. You don't need to multiply out all of the terms to know that you're going to get a term with x to the power of 18 as the highest power of x. For that, I've selected something that's kind of buried inside all of the brackets, working inside out. That's one way of doing it. Then I suppose you would take the highest power of the next thing, which is round bracket 3x to the 8 minus 12, all to the power of 4. The outside in way of doing this, the outside in way is to work your way inwards. That power of 3 on the outside, all that means is, well, we'll just have some sort of power of x from inside and look for, and then raise that, we'll cube that at the end. So let's not worry about that. And let's look at these square brackets next. And we do have to go all the way in to try and compare what the actual powers of x are. But maybe you could think about this as sort of, you've got some outer bracket and we're trying to find the highest power of x inside the curly brackets, which means then we need to look inside the square brackets, which means we need to look into the round brackets. If you prefer, this is, well, there are 2 terms inside each, 2 terms inside each round bracket, and then 2 terms inside each square bracket, then 2 square brackets inside the curly brackets. So overall, it's a kind of knockout competition, or bracket, if you will. It's a tournament bracket expressed with brackets. What a great question. It would help if there's a calculator. Yeah, you do need to multiply together 4 numbers. Sorry about that. It is multiple choice, so if you're a bit wrong on the multiplication, you'll notice, I think. How much progress can you make by noticing that it's a multiple of 3? You can eliminate C, can't you? That's interesting. 8, 9, 10. I think you can eliminate A as well. That's interesting. Oh no, do I? No, that's also multiple. You can eliminate C and A? Yeah, this should be a multiple of 3. And 44 is not a multiple of 3. Okay, so I get a 50-50 option on this question by noticing the 3 on the outside. Might take the 50-50. Yeah, okay, cool. So we're going to choose the largest powers as we work outwards. There's something to worry about here. Not a lot. I think you're all correct, by the way. I think it is D, that there's some power of x to the power of 504. The thing to worry about is what would happen if you had a tie during this knockout competition. Because if you have a tie, then the coefficients might cancel with each other. And I think in here, well, lots of stuff is positive. There's a lot of positive numbers around. Maybe it's all fine. But the thing to worry about is what would happen if you had, let's do a horrible example where I'm being mean. Let's put a minus sign in. So in this example, the first term has got a power of x to the 5 in. It kind of includes x to the power of 5. And this term also includes x to the power of 5. So in the case of a tie, you might think, well, I've got some x to the 5s and I've got some more x to the 5s, but that's okay. We'll just add them together and we'll get some other coefficient of x to the 5. But there's a problem which is there's a problem which is that the coefficient cancels out. Maybe you've spotted this. That this includes 2 to the power of 5x to the 5, and this includes 2 to the power of 5x to the 5. So, when you take the difference, the x to the 5 term cancels out. So actually this thing only, this thing is degree 4. And really I should check that the x to the 4 terms don't cancel out. They don't because of minus signs in the binomial theorem and it all being okay, trust me. But so hang on, there's suggestions for the thing on the board. You can get 480, but there's not an answer. You must be able to go higher. Oh, I see. If you just pick some of them, that's a great approach. So if you just do 7 times 4 times 6 times 3, it's like the powers just looking at the right hand side. 28 times 6, 28 times 18, goodness me. Or maybe you get something like this. Mumble, mumble, multiply, multiply. Oh, that is just 504. Does it just come from the right hand side every time? 7, 4, 6, 3. 28 times 18. Yep, it is just that. It is just if you spot that there's a 7 over there, and that gives you a massive power of x. This question's something you do. Hello to Year 10 kid who's just joined as well. We've got about 10 minutes on the stream, and we've got two more questions on the sheet, so I think I need to pick up the pace a little bit. Have I made my point? I think I've made my point that you've got to watch out for what happens when the powers might cancel, the coefficients might cancel. Yeah, 2 terms are the same thing. It didn't happen here. This question is lovely. Right, okay. It's another compare the options. We've looked for the smallest of some values. We've got largest of some numbers now, including log base 4 of 8, which we talked about before as being log base 4 of 4 times square root 4, which is 3 over 2. And there's other things we've got going on here as well. Okay, so we've got 4 things to compare. This time we want the largest, and they all involve logarithms, so that's nice, isn't it? I suppose we want to find a way to kind of compare these things. Maybe not directly to each other, but maybe we can compare these logarithms to known fractions. Like this one is equal to 3 over 2. So maybe we could compare the other ones to 3 over 2. It'd be nice if... Yeah, okay. Suggestions in chat are coming in. Let us go. Probably log base 2 of 3, not C. Compare it against this 3 over 2 stuff. Yeah, probably log base 2 of 3. That's the pick in chat. That's the idea that the chat wants to go with. Sophie says not C, because log base 3. Can I fit a chat on screen? Oh, not quite. Chat's going to hide one of the options. Let's have chat there for a minute. Log base 3 of 2 is less than 1 because 2 is less than 3. Log base 3 of x is an increasing function, and it hasn't yet got to the point on the graph where it would get to. Over here, 3 would be where log base 3 of x is equal to is 1. But no, you must be this high to ride, and we are still down here at 2. Log base 3 of 2 is less than 1. Somewhere down here, like less than 1. Tiny numbers. And I don't understand how it switches from less than to greater than, if that makes sense. So I guess the key idea is that there's the logarithm function is an increasing function. And there's a huge difference, isn't there, between this log base 3 of 2 and this log base 2 of 3, which is a different thing with log base 2, where log base 2, if you give it the number 2, you get 1 back out of your logarithm. If you give it the number 3, you get something larger than 1. So this is larger than 1, and that one's less than 1. I don't really have great intuition for why one of those is less than 1 and one of them's larger than 1. Maybe I do if I really think about it, but let's not worry about this too much. Ooh, reasoning in chat. Log base 5 of what I need to know. Yeah, well, now your chat message is on top of the log base 5 of the thing that you'd like to see. I worked out what I was doing wrong. It's this. This is why my toggle button stopped working, because I was on the other one. There we go. It's log base 5 of 10, and I think that's also larger than 1, but not much larger than 1. I really want to do that trend question in chat, but let's finish this first. Log base 5 of 10 is bigger than 1. How large is it? So that log base 4 of 8 thing, that's where 8 is quite large. It's 4 times the square root of 4. Is 10 larger than 5 times the square root of 5? That would, I mean, if it's equal to 5 root 5, then log base 5 of 10 would be 3 over 2. I think it's not, because if you square it, then on the left you get 100, but on the right you get 25 times 5 or something, which is like 125, which is behind me. 125, which is huge. So I don't think that's true. So I think log base 5 of 10 is actually quite small. It's smaller than log base 5 of 5 root 5. You know, I think 10 is kind of small because 100 is kind of small compared to 125. 10 is kind of small. I might change my question. Say, is it less than that? Yes. This is the power about going back and changing your greater than signs to less than signs if things turn out to be the way around. Yeah. Okay. Square root of 5 versus 2. Yeah, that works as well as a comparison between 10 and 5 root 5. I should have thought that. Divide by 5. Is 2 less than root 5? Yes, that's true. Root 5 is bigger than 2. Okay, I thought about squaring. I should maybe have just divided by 5. Good. One more, and that's to look at the same thing, but looking at A, where instead of 10s and 5s, we have 3s and 2s. So I should ask something like, is 3 less than 2 root 2? I think the answer is no. 3 is larger than 2 root 2. 3 is larger than 2 root 2 because, right down in the corner over here, sorry, 9 is larger than 4 times 2 is 8. 9 is larger than 8. Oh, true statement. Good. Okay, 9 is larger than 8. 3 is larger than 2 root 2. Log base 2 of 3 is larger than log base 2 of 2 root 2, which is 1.5. Okay, brilliant. All of those comparisons with something log itself, all of those comparisons with a log a, third time lucky, all of these comparisons I've been doing like 2 root 2 and 5 root 5 have been motivated by this idea that that's how logarithms of that give you 3 over 2. And we have this exact value. The option B is exactly 3 over 2. Squaring both sides, compare the squares. And if one of those options is exactly 3 over 2, then I want to use that as a kind of pivot or a way of splitting the options apart. Some of them are larger than 3 over 2, some of them are smaller than 3 over 2. And in fact, only one of them is larger than 3 over 2. The answer is A, because that's the only one that's larger than 3 over 2. We've got one more to go, which is another question of a similar format. Which of these is the smallest? And it's a mix of trigonometry, logarithms, square roots. I think we can simplify some stuff. So we've got just about enough time to simplify those logarithms. Hopefully you've now seen enough logarithms that when you see something like this, you're thinking, can I bring that power of 2 out the front? And then, do I know any facts that relate together? 3 and 9. 9 is the square of 3. So this is log base 3 of 3 squared. Maybe I should have done this all in one step or something. The thing inside is 81. 81 is 3 to the power of 4. So that's the largest. That's the number 4. And the other one over there, goodness me, that's a lot of log base 2. What's the other thing? What's going on here? Log base 2 of 8 to the 5. Well, 8 is 2 cubed. So this is log base 2 of 2 to the 15. 2 to the 15 is huge, but logarithm makes things smaller. If they're enormous, they get smaller. So this is log base 2 of 15, which, hang on a minute, 15 seems awfully close to 16, and 16 is 2 to the power of 2, 4, I think 2 to the power of 4. So I think this is a little bit less than log base 2 of 16, which is 4. We're off and away. We found something that's equal to 4, and we found something that's just a little bit less than 4. So it's like a good way into the question. So I think we're looking for the smallest this time. I think the others turn out to be larger than 4. So we've got that first one is 3 root 3. I think this is larger than 4. Is this thing larger than 4? We could compare the squares, a trick that we've tried to use a few times. Yeah, that is true. This is true. Compare the squares works well for positive numbers. I have this true statement. 27 is larger than 16. And we also know facts about sine 60 degrees. I will let you finish off the question by calculating with sine 60 degrees. We've got an episode about trigonometry coming up in a couple of weeks. It's a perfect segue to a future episode. I think the answer turns out to be D, the only one that's less than 4. I think that's sine 60. I might be wrong. I think we get a root 3 over 2. We end up with something kind of large again. Yeah, okay. Let me know in chat. So some people are saying D, I says D. Everyone said it was B. Oh, and then you had a guess. B was kind of large, but A was slightly larger, like that previous question. And then in this one, it turns out that D is the smallest. All the others are larger than 4. Quick look at chat, just because I've got a working button to look at chat now. D, which is the only one you can't see, is the largest out of those options. I think we've got to the end of the questions on the question sheet. I can very quickly do questions from chat if anybody wants to do this. Oh, there's some lovely stuff going on in chat. Yeah, Maya's calculated C for me. Thank you with your trigonometry stuff. Good times. Thank you for spotting a typo in the solutions earlier, and one of the revision notes really needs more explanation. So thank you for the corrections and suggestions for the live stream notes. I hope you found that useful, or at least maybe at some point I made you think about logarithms in a slightly different way, or with a slightly different kind of fluency, or a slightly different kind of attitude to moving logarithms around. I think the actual calculations that we've done are not too bad. The thing that I want you to practice over the summer, I guess, is just being happy with switching between logarithms and powers, so that if you need to, you can switch to the other way of looking at things, and that might give you a fresh insight into the question. There is an extension. Yeah, sorry, I haven't talked about the extension at all. There's an extension in there somewhere to think about 8 factorial to the 9 and 9 factorial to the 8. Which of these is larger? It's a kind of bit of a classic question in the sense that I'd seen it in a couple of other places before I put it down as the extension on this sheet. Here's a fight between 2 fractions. My suggestion, if you want to try this, is to simplify the ratio between those 2 things as much as you can. If you want to see the solution, it's in the solutions doc, which is on the MAT Live website, where you can get, as of time of recording, you can get all of the questions and solutions for upcoming live streams for the next 3 weeks. Speaking of, we will see you next time in 166 hours, this time next week, for another episode of the Oxford MAT Livestream. But until then, if you've got any questions, you can contact us with the email address in the YouTube description or the contact us link at the bottom of the MAT Livestream page. And we will see you, not mixing up largest and smallest. We did have several in a row asking about large and small numbers. We'll see you next time for another episode of the Oxford MAT Livestream. Yeah, solutions and chats. Okay, don't look if you don't want the solutions. Okay. Good. Yeah, brilliant. Right, bye.